There are 8 inferential statistic tests that AQA A Level Psychology expect you to understand the selection criteria for. You need to be able to read the details of a given study and decide which criteria have been met and therefore which of these 8 tests is appropriate. There are 3 main decisions that you need to make when selecting an appropriate statistic. The first decision you need to make is whether your study is testing for a difference or a relationship. To be able to identify whether a study is a test, a difference, or relationship, you need to firstly identify the 2 main variables that are present in the study. Once you've identified the 2 variables in the study, you then also need to identify which of those variables were measured. In an experiment, only one of the variables is measured, the dependent variable. Therefore, experiments are tests of difference, as they are looking to study the difference in the dependent variable between the different conditions of the IV. This is what allows us to determine cause and effect. Whereas in a correlation, both variables are measured. There are no conditions. This means we cannot determine cause and effect, only that the 2 variables have a relationship. Here you can see that only 2 of the statistical tests are appropriate for tests of relationship, and the remaining 6 are appropriate for experiments. So looking at an example study, Study 1 talks about comparing therapies and measuring the effect on satisfaction with life. Those are the 2 variables in this study. Only one of those is being measured, the life satisfaction. So this is our dependent variable because it's being measured on a rating scale out of 30. And then our IV, our conditions, are the 2 therapies. Therefore, study 1 is a test of difference. In study 2, there are still 2 variables: GCSE exam paper on maths, and the second variable is the music ability rating scale on a scale of 1 to 10. However, neither of these refer to conditions. Both of these variables are just being measured. The teacher in this study is not comparing 2 groups of students, only measuring their GCSE score and seeing if it's related to their musical ability. So this study is a test of relationship. The second decision you need to make when choosing your inferential statistic is the level of measurement. The clue is in the name here, level of measurement. So therefore you need to be looking at the variables in the study that are measured. In an experiment, that's just the dependent variable and not the IV. In a correlation, that's both covariables. When identifying the level of measurement in a given variable, the first question to ask yourself is that variable being recorded in categories? Could it be put in a tally chart? For example, 10 participants said they feel stressed, 3 participants said they did not feel stressed. That would be nominal level of measurement. However, if the variable is on a scale of some kind, then you need to consider that scale to decide whether it's ordinal or interval level of measurement. If that scale is a generally objective, universally agreed scale, where the units have equal intervals, then your level of measurement is interval. For example, seconds. Every unit on the scale is exactly equal to the other. 5 seconds is exactly half 10 seconds. And it is the same for everyone. However, if you are rating something on a scale of 1 to 10, one person's 5 is not exactly half another person's 10. Someone's 5 could be equivalent to someone's 10. There is no universal agreement on a rating scale. Nominal is the most basic level of measurement of the three, and interval is the most sophisticated. You can convert interval down into nominal, but you cannot convert nominal up to interval. This is generally in line with the complexity of the tests, with the more straightforward calculations being for nominal data and the more complex calculations being for ordinal and interval. So then going back to the studies, study 1, we already identified that the dependent variable was the satisfaction with life score. So this is the variable we need to look at to decide level of measurement. So satisfaction with life, rating out of a possible score of 30. So there is no categories suggested with this, so it's not nominal. It's a score, so that suggests it's a scale. However, there's no universally agreed life satisfaction scale. Different people will have different opinions about what a 30 looks like, what a 20 looks like, etc. Therefore, this variable is an ordinal level of measurement. Study 2, we already decided was a correlation. Therefore, both variables are being measured. So for a correlational study, we need to look at the level of measurement for both. The first variable is their mathematical ability on the GCSE exam paper, and she's recording their mark. Mark is a synonym of score, which suggests that it's a scale of some kind, so again, not nominal. Although you could argue that GCSEs are standardised, not all marks on a paper are equal. Some are multiple choice, some are more extensive. And so therefore you can't say that the units are definitely equal. So the safest option here is to say that we've got an ordinal level of measurement from the GCSE exam paper. The second variable is her rating of their performance on a scale of 1 to 10. This is much the same as the variable in study 1, where there is a subjective opinion given on a scale, and so therefore this variable is also ordinal. I've got just a few examples here just to more clearly illustrate the difference between nominal, ordinal and interval, particularly the difference between ordinal and interval, where although both are scales, the examples in the interval column are objectively, universally agreed scale measures. Whereas the examples in the ordinal column are all involving subjective rankings of happiness, test score, etc. In the nominal examples, the dependent variable very clearly has named categories, either explicitly stated like in the first example, or did or did not smoke, or did or did not complete the questionnaire. The final decision when selecting inferential statistic is whether your data is considered related or unrelated. Unrelated data generally refers to the fact that you're only collecting one score from each participant. This is true for independent measures designs for experiments. This is because each participant is only completing a single condition, and therefore you're only recording the dependent variable for that person once. Therefore, all of your data points are not linked to each other. They are all from different participants. Whereas in a repeated measures design, each participant is completing each condition, and so therefore you're collecting two scores from each participant because you're measuring the dependent variable in each condition for each person. This is also true for matched pairs, where you treat each pair as one participant. For a correlation, because you are measuring both of your covariables, you're therefore naturally collecting and measuring two scores from each participant. This means that although you still end up with two pools of data from each condition or for each covariable, you can link two or more of the data points to each other. So although you've got the two separate pools, the X score and Y score are from the same participant, so those data points are linked and related to each other. This means that when identifying whether you've got related or unrelated data in a study, I would always try and identify if it's an independent measures design first, because it's normally easier to spot and is the only thing that's considered unrelated. If you haven't got an independent measures design and you haven't got two separate groups of participants doing different things, then you know that you've definitely got related data. And then you're just searching for evidence to figure out which kind of related data that is. You can see here that just over half of the 8 tests are for analysing related data. Going back to the studies then, we now need to decide whether we've got related or unrelated data. So with study 1, we've already established that study 1 is an experiment. Therefore, we need to identify the experimental design in order to be able to make the decision about related or unrelated data. This scenario is quite nice as it makes it very clear which experimental design was used through the use of one particular word, and that is the word matched. So this tells me that a matched pairs design was used, and therefore we have related data, as we can treat each of the matched pairs as one participant for the purposes of analysing data and calculating statistics. Study 2 we've already established is a correlation and is looking for a relationship between the two variables. Therefore, just for the nature that it's a correlation, we know already that it's related data, where the GCSE maths mark is related to the performance mark, as you're collecting both for each participant in this study. To then make a final conclusion on statistical test, you then need to put those 3 decisions together. So from our analysis of the scenarios, we know that study 1 is a test of difference. We know that the level of measurement is ordinal, and we know that we've got related data. Therefore, if we go back to the decision table and we look at test of difference, ordinal, and related data, Wilcoxon is the most appropriate statistical test to analyse the data from study 1. If this was an exam question, this would usually be up to 7 marks, where one of those 7 marks is for naming the appropriate stat test. 3 of the marks are for naming the appropriate related criteria. And the final 3 marks are for contextualizing the criteria to this study. So, for example, saying that the satisfaction with life rating is ordinal level of measurement because it's a subjective opinion about life satisfaction. Study 2, we've already established, is a test of relationship between the GCSE maths mark and the performance rating on a scale of 1 to 10. We've also determined that both of our covariables are ordinal. And because of the nature of the study being a correlation, we also know that we've got related data. So again, if we go back to the decision table, looking at the 2 tests of relationship, we've got only the options of Pearson's and Spearman's. Because our data is level of measurement is ordinal and we've got related data, Spearman's row is the most appropriate statistical test to analyze the data from study 2. The key with choice of stat test questions is breaking it down and taking it step by step and really considering the specific study that you're looking at, making sure you very clearly contextualize your answer to that particular study rather than studies like that generally. Unfortunately, you do need to get to the point where you can write or draw out a form of this table in your exam papers, as this will not be given to you. There's no magic fix with this, unfortunately. It's just a matter of looking, covering, writing out, checking, rinse and repeat. There's also just one other thing that I want to really iterate at this point, and that's about the Pearson's and Spearman's tests, is that they are the only 2 relationship tests, but they are also different in the sense that you do need to look at the level of measurement for both covariables. So technically, if you want to be really precise, the criteria for Pearson's is that both of your covariables need to be interval, and for Spearman's row, both of them need to be ordinal. So if you're in a situation where you're reading a study and one is ordinal and the other covariable is interval, you cannot use Pearson's. You have to use Spearman's. The only instance you can use Pearson's is if both are interval. For example, seconds and heart rate. If, for example, it's something like heart rate and stress rating, then you would have to go Spearman's because the stress rating would be ordinal. So that's covered the 3 main decisions that you need to make when deciding on a choice of test for your AQA A Level Psychology papers. You can stop the video here, but I am going to talk through a little bit more about some extra criteria for some of these tests for anyone who is interested in pursuing psychology after college at degree level, or another course that has a statistics component. If you are ending the video here, then thanks very much for listening. I hope it's helped to clarify some of these decisions that need to be made for statistics. So 3 of these tests do have a couple of extra set of assumptions, extra criteria that also need to be met, as well as the test of difference relationship, level of measurement, and related or unrelated data. Depending on other A-level subjects that you study, you might have come across these tests being referred to as parametric before. If you haven't, it's not essential knowledge for AQA psychology, but it is a really key part of psychology research methods. The first extra criteria that needs to be met for these tests is a normal distribution. So this is something that you have actually looked at in the A-level already. So what we want with our data sets from both conditions or both covariables is to look like a normal distribution, a nice symmetrical bell-shaped curve. We don't want any of the data, either overall or between conditions or covariables, to be positively or negatively skewed. The second extra criteria that's required for the parametric tests is something called homogeneity of variance. This is basically, essentially, as you can see from the images and the values, the idea that your conditions or covariable set data sets are similarly spread out or not spread out. That the variance, the spread, is the same roughly in both. If these extra criteria aren't met, then we would use a non-parametric equivalent, which is a selection from the others in the decision table. This is usually the test for the next level of measurement down, but for the same type of data, so related or unrelated, and the same type of test, so test of difference or relationship. So if you wanted to do the related t-test but you had skewed data, then you would use Wilcoxon. If you couldn't use the unrelated t-test, then you would use Mann-Whitney. And if you couldn't do Pearson's, then you would use Spearman's instead. As I was saying before, these extra set of criteria are by no means essential for A-level psychology, but they are useful and interesting if you're considering pursuing something psychology or statistics related later in life. If you made it right till the end, then well done for sticking with it, and thank you for listening.